What's up, guys? Okay, let's get straight into our lesson about the experiments that we watched. So remember, this experiment was about investigating the formula of a metal oxide. We're gonna be using copper, and the oxide, obviously that's just oxygen, so copper oxide. So we're gonna try and find out what is the formula, what's the chemical formula if we do an experiment. Now remember the experiment, that scientist, he had that empty dish that he placed inside this boiling tube, and then he put some hydrogen gas, flushed out all the oxygen gas, and then he put some heat here with a Bunsen burner. And eventually, when you burn that copper oxide, that CuO, when you burn that inside this hydrogen containing cylinder, if you will, what eventually happens is this oxygen molecule rips off, combines with hydrogen gas. It's sort of floating around all over here. That's going to give us water, which we saw with the little droplets forming, and then we're going to be left with copper remaining behind, that brownish metallic looking substance. Okay, cool. So that was, if you didn't understand that quick summary, just go and watch the experiment again. Really important to understand the steps and all that. But what about calculations? So first thing we have to do is we have to weigh that empty dish. Okay, before that empty dish I'm talking about is that one there. Before we put any copper oxide, which is that sort of black stuff there, before we put any of that on, we have to weigh the empty dish. So the empty dish weighs 23.78 grams in this example. In the video example, it'll weigh a different amount. Okay, then we put our copper oxide on, put like a spatula full. I think we're going to try and use 3 grams in this example. So we put 3 grams of copper oxide, so the empty dish plus the copper oxide, that's going to give me a value of 26.96 grams. Okay, then we burn through with the heat, and we start to notice condensation, we start to notice water droplets, and eventually we carry on burning, and we let it cool down, and then we weigh the dish. It's not empty anymore. Excuse me. So we weigh the dish after the experiment. Okay, we weigh the dish after the experiment, and we get a value of 26.32 grams. Okay, so this is the crux of this calculations, is you need to use these values to work out how much does copper weigh and how much does oxygen weigh. Remember, after the experiment, we've just got copper remaining over here. Okay, so to work out what is the weight of copper oxide, well, remember we've got copper oxide, we've got copper oxide plus the empty dish, and then we've got the empty dish over here. So if we simply say 26.96, that's this value here, minus 23.78 grams, that's obviously 23 from there. This is going to give us the mass of copper oxide. So the mass, if you just type this into your calculator, 3.18 grams. Okay, cool, that's copper oxide. But now, what is it going to weigh? What's the copper going to weigh? Well, at the end of the experiment, the mass of this dish is 26.32. Okay, and with the initial empty dish, it's just 23. So if we take these two values and we subtract them from each other, we'll get just the mass of copper. Okay, so we can say 26.32 minus 23.78, and this is going to give me 2.54 grams of just copper. Remember, when we heat this up and we expel all the oxygen, only copper remains. So whatever that mass is over there, which we weighed 26.32, and the empty dish, which is just the dish itself, then that's obviously going to give me copper. Okay, cool. What about oxygen? Well, oxygen, we can see if I've got 3.18 grams of copper oxide, that I worked initially, and I've just got 2.54 grams of copper. The rest of this mass is going to be the oxygen. So I just simply have to go 3.18 minus 2.54, and this will give me, this is going to give me, I've worked this out on a piece of paper, 0.64 grams of oxygen. Okay, so let's give ourselves a bit more room here. So we've got copper, which gives me 2.54 grams, and I've worked out oxygen is going to give me 0.64 grams. Okay, now I'm trying to find out the empirical formula for copper oxide formula. So what do we do with empirical formula? We've been given grams, we know this already, we have to work out the moles. So moles equals mass over molar mass, and so the moles for this one, it's going to be the mass is 2, or for this one I mean for copper, 2.54 divided by the molar mass of copper is 63.5, and this amount of moles is going to give me 0.04 mole of copper. Okay, let's just try to split this up. Okay, oxygen, same formula. Just put this through, so it's 0.64. I know the molar mass of oxygen is 16, and this is actually going to give me the same answer, 0.04 mole of oxygen. Okay, now remember, when we're working out the empirical formula and we are working with two different elements here, copper and oxygen, doesn't matter if we're working with 3 elements or 4 elements or 5, we divide by the lowest number. So we can see it's the same here. Going to divide by 0.04, that's going to give me 1, divide by 0.04, that's going to give me 1. So the empirical formula here is going to be copper and oxygen, just one element of each. Okay, so that's the experiment, and that's how we get to the empirical formula. I hope it's been really helpful, and I'm going to do one more experiment, and then we are done with working out empirical formulas using experiments. In the following module we're going to be using, or in the following modules to come, we are going to give you techniques how to work out empirical formula. And in fact, we've already done this in class, where I can give you percentages of certain elements, like 54% carbon. You'll be able to work out the empirical formula. We've also done examples of giving you the empirical formula and then also converting that to molecular formula. If we give you the molecular formulas, the molar mass of that molecular formula. So go and have a look at that live session from yesterday. That's Thursday. And then go and have a look at Wednesday's live session as well. Okay, one more video and then we are done with empirical formula.